Alright, 4.8 in Advanced Algebra 2, profit today. Three major words dealing with a profit situation: revenue, cost, and profit. Let's define them first, and then we can get into some examples. Let's talk about what revenue is. Revenue is the money received for selling a product. Like if you sell a microwave for $50, that is your revenue in that situation. So you can pause the video to get these written down if you need to. Money received for selling a product is revenue. The cost is pretty obvious. It's the amount of money you, the retailer, spend on making the product. The amount of money you, the retailer, spend on making the product. So the profit will quite simply be your revenue take away your costs. And we have some examples of that right now. Again, get these written down if you need to pause the video. So let's check out the first one. Let's put an example with all these words here. Steve makes microwaves. It costs him $20 to make each microwave. So let's let X stand for the number of microwaves that he's making. So his cost equation would be C equals 20 times X, because it's $20 for every microwave that he makes. So that's what it costs him. But at his store, he sells each microwave for $50, meaning his revenue equation would be R equals 50X, because he makes $50 for every microwave. Find Steve's profit equation. So quite simply, profit equals revenue minus cost, and we could substitute in profit will equal the revenue, doesn't he make $50 per microwave, take away the cost of $20 per microwave, and since those are like terms, his profit equation would equal 30X. That's pretty obvious in that situation that Steve makes $30 for every microwave because he sells them for $50, but it cost him $20 to make. So that's a real simple example of revenue, costs, and getting your profit, because profit equals revenue minus cost. So here's another one. It costs Apple $4.25 to make a pair of earbuds. They then sell each pair for $15. Part A wants us to define a variable and write a cost equation for this scenario. So let's let X equal whatever the heck they're talking about, the number of earbuds. X can be the number of earbuds. And then the cost equation is what they want us. Cost equals $4.25 times every pair of earbud that they make, which is X. The revenue equation, well, how much money are they making? The revenue is $15 per pair of earbuds. And the profit equation, the profit would be revenue, 15X, minus the cost of 425X, and those are like terms. So the profit will equal 15 take away 425, which is a big old fat $10.75 per pair. That's what Apple profits. So there's their profit equation. So pretty simple concept here. On the next one, the daily profit for a product is given by this equation right here. Notice now we're getting a little more fancy that it's quadratic, where X is the number of units produced and sold. Find the profit if 0 units are sold. Well, if 0 units are sold and X stands for the number of units, all we got to do is put 0 in for X. So if I put 0 in for X here, that's going to turn out to be nothing. Right? If I put 0 in for X, that's going to turn out to be nothing. And check it out, we have a negative $1,000. It's like the profit is a negative 1,000, meaning you're in the hole, right? Wow. Well, why do you think that is what part B is because if you're going to start a company, I'm sure that there's some setup costs and all that. So it's most likely there's setup costs. I mean, think about Steve and his microwaves for a second. You know, it's like originally when Steve wanted to start making his microwaves, he's going to have to, like, first of all, buy the materials to make it, so he's got to spend some money there. He might have a building that he's renting to do all the work, and he's got some tools to put them together. So there's some sort of cost before you even get started. Then they say graph this function on a window of this, which we've never seen before. So let's pull up the old calculator. And I went ahead and got that typed in already. I'll let you pause the video if you need to and get this equation typed in correctly. And then a lot of times in some algebra problems, they will tell you the window to graph this in. So if we go to the window button, all of these in this first bracket right here represent stuff to deal with your x values. So this is your x minimum right here. They're saying the x minimum is a negative 100. The next number is this number directly below that, which is your x maximum of 3200. And then the next number, that's the scale they want you to count by. So they say use a scale of 100. So you just went from negative 100 to 3200 on the x-axis, counting by hundreds. Then you skip down to the y's, and this is what this second bracket of information is. Y bracket of, y minimum of negative 2000, maximum of 25,000. Yeah, come on. And then counting by thousands. And remember that last down there is that x resolution. We'll always let that be a 1 in that situation. So let's hit graph and see what this bad boy looks like. Should be a very nice graph of this quadratic, which is a parabola that opens down. So we graphed it. Q. It says what happens to the profit for this product when the units produced between 1 and 1600. So 1600, remember that's right smack dab in the middle. If you wanted to actually figure out what that is, if you hit trace 1600, since 1600 is a x value, that would put your cursor right up there at the vertex of that bad boy. So they're asking you what's happening to the profit for this thing. Well, this is what's happening to the profit. They're wanting to know if it's increasing or decreasing. Well, that profit is increasing in that situation. Profit is increasing. And then they ask what happens to the profit after 1600. Well, profits are going down, so the profits are decreasing. And let's kind of understand this a little bit more. The profits are decreasing, but they still have a positive profit. Like right here, let's just say, okay, that's 1600. Let's trace 2000. Let's say they made 2000, whatever the heck they're making, they don't even tell us. Notice that's in the decreasing zone right here. Well, they still have a profit of $23,000. It's just not as much of a profit. Like right here where the profit maxed out, like that vertex is the maximum profit that they would make. They still have a positive profit all the way until they get back down here to 0. Like after they make this many I guess we don't know what they're making. After they make this many of the product, all of a sudden they broke even again, and then they start going into negative profit. Well, the reason behind that is like easy way to explain that is, let's say they were making like iPhones. Like say it was just the iPhone 6, and it's like obviously you can't make a bajillion iPhone 6s for a lot of reasons, because one, there's not that many people to buy them, and two, if you make so many of them, you're gonna like just be sitting on them, because eventually something better is gonna come along, like the iPhone 7, and it's like, dude, you can only make so many before you maximize your profit, because there's not a need for an iPhone 6 anymore. So realize that this is all positive profit up in here. It's just this vertex was where the maximum was. So that's what they're asking us right here. It says the profit for easy cut lawnmowers can be described by this function, and yes, you will be able, if you go further in math, to figure out how these functions are found. We'll do that in FST, where X is the number of mowers produced and sold, so they're making the lawnmowers, right? Is this function linear or quadratic? Well, obviously it's quadratic, because the biggest exponent is a 2. To maximize the profit, how many mowers must be produced and sold? I don't even really need to graph this situation. I know he's a parabola, and I know he's going to open down, and I can tell you right smack dab where ye old maximum will be. Boop! Right there. Find the vertex. I'm going to do that algebraically. To find the x value of the vertex, remember that's the opposite of b over 2 times a. So opposite of b, negative 840, because this guy was in standard form. 2 times a, negative 0.8. And then we do a little calculating. Quit out of this. Remember, if you can't, if you're not sure how to get out, you hit second, quit, and then 840 divided by 0.8. Since they're both negative, I got rid of those right away. Negative over negative is positive. That's 1,050. So 1,050 mowers, because that's the X value. What is the maximum profit? Well, you got to find the Y value of the vertex, right? So this was 1,050 mowers, and now all I have to do is substitute 1050 in for X into this situation. Remember, you're putting that into parentheses. So I will let you calculate that real quick if you pause the video, because it takes me so long to punch this in. And this is what I got. I just substituted all that stuff in. Just make sure you got that little guy squared. A lot of people accidentally forget that. And it's a big number. It should be a big number. We're talking about the profit of making mowers, so $440,000. What's the rest? $924.40 is the maximum profit. So if they made this many mowers, that would be their profit. Now, if they made some more mowers than that, they'd still make a profit, but they'd start losing some money. The situation, because they're making more than what they are selling, is basically the kind of the moral of that story. So let's do some big story problems.
Here we go. Emily has her own business where she sells refrigerators. She sells refrigerators for $550. So her revenue equation is R equals 550X, where X is the number of refrigerators she sells. All right, $550 a piece. Sound good with that? It's true, folks. If you take FST, these equations aren't just made up. You can actually figure them out, but you'll do that in FST with a little regression formulas. So she did some research about the refrigerator she was selling, and this was her cost equation. The cost equation turned out to be this quadratic guy right here. Sound good? So find the equation for Emily's profit. Here's what we're going to do above it first. Make sure you got yourself room to draw your graph over here also. Sorry about that. We got to do a little bit of algebra, and keep yourself that little box for the graph. Profit equals, what's the formula? Revenue minus cost. I want you to write that down first. P equals R minus C. Profit will equal revenue minus cost. Cool? So let's start. We'll definitely have a P equals. Do you know an equation for her revenue? 550X. Right? Revenue, 550X. That goes in here. All good? I now need to take away the cost. Does the cost equation have more than one term in it? That's why you need to put that in parentheses. Take away that whole thing. When you want to take away more than one term, it needs to be quantified. Awesome sauce? We need to clean this up. Is everybody cool with the fact that I need to distribute this negative through right here? All right? So I'll have P equals 550X minus X squared minus 30X minus 10,000. So far, so good with what I've done. Any like terms that I could combine? X's, right? So let's keep this in standard quadratic form. Profit will equal negative X squared. 550X and negative 30X is how many X's? A positive 520 X's minus 10,000. This is the profit equation. Revenue minus cost. Cool? So I'll box that bad boy up. This is the guy we want to graph. Cool? It would be a nightmare to graph if you didn't find one point first. Who's the first point you got to find? Vertex. Yes, let's slow down. Let's think about something. What if she sold 0 refrigerators? X is the number of refrigerators, so let's put 0 in this equation real quick. What would this turn out to be if I put a 0 in there? 0. What would this turn out to be? 0 minus $10,000, right? She sold 0 refrigerators. Her profit is negative $10,000. How come? She hasn't sold any refrigerators yet. How come she's lost $10,000? It takes money to start this business. She's got to make all the refrigerators. She's got to have a building to sell them out of. She's got to pay the rent on that building. She's got all these costs, correct? So when she started this refrigerator deal, She's already in the hole, 10,000 bucks. When we make our graph, will I need a negative portion of my graph? Because she's already in the hole. You with me on that? Cool. Find the vertex, please. Find the vertex. I got 260 for an x value. What is the y value of that bad boy? 57,600. Correct? 57,600. You've got to put that in parentheses. Let me show you the mistake that people make all the time. They don't put the stuff in parentheses. You need to do, let me get this out of the way here, negative, parenthesis, 260, close it up, squared, and then punch the rest in. The negative is in front of the parentheses. Does that make sense when you're punching that stuff in? So I want you to think about this. How long would it have taken you to find the right window if you didn't find the vertex first? The maximum of that graph is at 57,600. How long would you hunt and hunt and hunt and hunt for that? Forever. You'd probably never find it. You would never find it. You know what I mean? It's like it keeps going up and up and up and up. Find the vertex first. So let's punch this bad boy in and graph him. It's negative x squared plus 520x minus 10,000. And let's go to our window. X values. Best idea is to take that x value and double him, right? Because remember, that's going to be like the line of symmetry down the middle of that. So this is 260. Double that is right here with that number again, that 520, right? So I'm going to go to, let's try 600. I'm going to double him and add some more. So I'm going to go to 600. That means I need to change my x minimum because I'm probably not going to count by ones. What do you want to count by to get up to 600? What do you want to count by? Hundreds? Okay. So then I'm going to make that x value, this negative guy right here, negative 100. Y maximum. Let's figure him out before we do the y minimum. Y maximum. How high do I have to get? We might as well go to 60 grand, right? We might as well go to 60,000. And I pray that you don't count by ones. What do you want to count by? 10,000. Great suggestion. What's the minimum I got to get to also? Remember, we're not starting at 0. This has got some negative profit to it. So what do we definitely have to get to? Negative 10,000, right? I'm going to go down to negative 20,000 just for fun. Let's see what that looks like. Because I'm counting by 10,000s, man. You know, like that's just 2 ticks. With me? Let's see what he looks like. Is that a decent view of that parabola right there? All brought to you by finding the the vertex first. Finding the vertex, knowing what to do. Cool? So, let's do some stuff. Nice. Scale. We're counting by hundreds again, right? So let's figure this out. That's 100, 200, 300, 400, 500, 600. Don't I have to have 6 spots available? Counting by hundreds. So 100. You can turn your paper to the side a little bit if you don't want to write long ways. So 100, 200, 300, 400, 500, 600, 800. You do need to go negative, though. Notice I have that 4th quadrant brought in a little bit. Counting by hundreds, but I didn't want to write all of them, so I just did every other one at 200, etc. And then get your y-axis scale on there, baby. You're going by 10,000s. Don't forget to label your axes. We're running a little shy of time, guys. So what's on the x-axis? What are these numbers? It's not time in seconds anymore. What are the x values? Number of what? Refrigerators? Number of refrigerators. What's on the y-axis? What are those big numbers over there? It's this P. What do you think P stands for? Profit in what unit? Dollar bills, y'all. Profit in dollars. Where did she start? Negative 10,000. She sold 0 refrigerators. She's got negative $10,000 to her name. Yay, debt. I know the vertex is at 260. 57,000, blah, blah, blah. $260, 57,600. If the bell rings, just hang with me. We'll finish this real quick, not much longer. Next thing I'm going to do is I'll skip these for a second, and let's go down to part I. What is the break-even point? Break-even point means when your profit is how much if you broke even? Profit is 0. So that's why we'll graph y equals 0, because y is our profit, y equals 0. And then look at it on the graph. How many times does that parabola cross the x-axis? Twice. She started at negative 10,000. Won't she break even right here? Right? Then you keep selling fridges, keep selling fridges, keep selling fridges. The fridges start to go out of style. It's like, oh, I don't like that refrigerator anymore. If she kept selling the fridges, and sold this many fridges, wouldn't she have $0 again? So find those two places. Second, calculate, intersect. First curve, second curve, enter. 20. Is that what you got for one of them? Did somebody find the other one real fast? 500. Thank you. I trust you know how to do that. Find both of them. So if she sells 20 fridges, that's where she'll break even for the first time, right? Then she has enough to sell 500 fridges, but then she'll be at even again. Would you, if you were Emily, want to sell that many refrigerators? What is the point that maximizes your profit? The maximum. How many fridges should she sell to maximize her profit? Maximum of the graph is how much? 260, right? You use algebra to figure out 260 fridges is the right amount to sell. So it says, how many fridges should she sell to maximize the profit? 260. What is her maximum profit? $57,600. I want to do one other one before the bell rings here, how to answer it. What is Emily's profit if she has sold 10 refrigerators? What is refrigerators, an X value or a Y value? So let's trace 10 and see what happens. Trace 10. What do you got? Negative $4,900, right? What's her profit? $4,900 loss. She doesn't have a profit yet. Doesn't she have to sell 20 refrigerators before she's even going to start to make some money? So if she sells 10 refrigerators, when you get a negative profit, that's called a loss. Friends, does that make sense? So you still write it as $4,900, but you put the word loss. Or you could say loss of $4,900. But the word loss means you are negative profit. Okay? If you have any questions, please come see me and I will help.
All right, last one. Margot has her own business where she sells couches. She sells each couch for $1,000, so that's her revenue. After a few years of research, she found that her cost equation would be this, so here's her cost. Find the equation for Margot's profit. So, since profit equals revenue minus cost, I'll let you do that. Please pause the video and get that done. And I got the profit to equal negative x squared plus 2,204x minus 1,800. Remember, you had to subtract away that entire blue equation right there, expression. So all the signs change because you got to distribute that negative. Find the vertex of this parabola algebraically. So x will equal the opposite of b, so negative 2,204 over 2 times a, negative 2. And that would be 1,102. That's the x value of the vertex. And now find the y value of the vertex. by substituting this into this equation. Remember, you must put this in parentheses so the negative goes outside the parentheses when you're punching this in. It's, well, I got to get this out of the way, sorry. It's negative parenthesis 1102, close that up, squared, etc., plus 2204 times 1102 minus 8800. And yowza, that's some big profit right here. That's over $1 million for the maximum profit. So write a nice little ordered pair. That's the vertex. And remember, the reason why we wanted to find the vertex is because that's going to help us find the window for us to graph this situation. So let's bring up ye old graphing calculator and let's punch that in. So it's negative x squared plus, you can read it, you know, just get that bad boy punched in. But now we need to find the right window. Instead of just guessing and checking, that's why we found the vertex first. So I guess I'm not going to clear all that out, but to do your x minimum, okay, I really like to think of the x maximum first. This vertex is like halfway. So I'm going to double that, and that's going to be that 2204. I'm just going to go a little bigger and go to 3000. I might as well go all the way to 3000, and I'm going to go to like negative 500 on my x minimum and count by 500s. Really, what you count by doesn't matter, and the x minimum isn't that important. It's just x maximum. You want to double the x value of the vertex and just go a little more. Well, y minimum and y maximum, you know this guy's starting $8,800 in the hole, so I might as well go to negative 10,000 because that's your y-intercept right here, like this negative 8,800. I got enough zeros, yes. And then the y max, you definitely got to get up to this 1,200,000 and some odd thousand, so I might as well go to 1.5 million. So 1, 5, and then 5 zeros. There's 2, 3, 4, 5. I just want to go bigger than this, and since I got to go up to 1.5 million, I might as well count by like 100,000s. There's 100 and then 3 zeros. So graph it. You should see the parabola where it crosses the x-axis in both places, and you should see the maximum. So that looks pretty good to me. I'm just going to kind of label that I went to 3,000 over here, and I went to 1.5 million. Might as well just kind of keep counting by 500,000. So there's 1 million, and there's 500,000. And then this was 2,000 and 1,000. 2. Alright, so let's make a rough sketch of this situation. Let's plot our y-intercept of negative 8,800, which would be way up here, because remember, you're counting by some serious stuff. So 0, negative 8,800. The vertex, 1,102, so that's about just like right here, 1.25 million, 1102, 1205, throw a comma in there, 604, boom, boom. And it says, what is Margot's profit if she sold 10 couches? So this is the number of couches, right, on the x-axis scale, number of couches. And this is the profit in dollars on the y-axis scale. If you sold 10 couches, well, that's where the calculator is going to help us now. Since 10 is a x value, I can just trace 10, and her profit is the y value. So $13,140. $13,140. What is Margaret's profit if she sold 888 couches? So trace 888. Trace 888. And that's a nice big number. 159,808. 159,808. So 2. How many couches must she sell to have a profit of this much? This is a profit, so that's a y value. So you go to y equals and you graph that guy as the second equation, 872,675, and then you go back and graph it. And then we need to calculate the intersection. So second, calculate choice 5. First curve, enter. Second curve, enter. Guess. It'll take you to one of those. So 1679. And second, calculate 5. First curve, second curve. Now I got to move my cursor over closer towards that other dude. So it will calculate that one. 525. So 525 and as many couches. And let's put all that stuff on the graph right there. Well, I guess we need to find a break-even point too. What is her maximum profit? We have that. It was 1,205,604 because that's the y value of the vertex. She needed to sell 1102 couches. And what is the break-even point? That is right down here and over here. So y equals 0 is where that is. And enter. Let me clear that out. Sorry. 0. Enter. Window. I'm going to change my y minimum so I can actually see this a little bit better. So I only went to negative 10,000. Let's go to negative 100,000. So graph. Now I have a little bit better view to see those. And now I'll do the second, calculate the intersect of those. First curve, second curve, enter. It will find one of them for me at 2200. And then there is another one, right? It's way over here. So second, calculate. And then let's, first curve, second curve. Move that cursor over there closer. It's hard to see because you got all those dang numbers in the way. You could have went to negative like 500,000 maybe on the y minimum to see a little bit better. Not great. Enter. 4. So 4 couches and this many. Oh, yeah, couches. So they started in the hole, right? They started at $8,800 in the hole. After they sold 4 couches, they broke even. Then they could sell more and more and more and more and more. And then if they sold all the way up to 2,200 couches, they'd basically break even again. They'd have 0 profit. So let's put all these points on our sketch. That was at 40, 2,200, 0. And nice parabola, la 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 la. And then we can plot that 87265, which is probably about right here, as a horizontal line, and say that was at 525 and 1679. So there you go. Let us know if you have any questions, and have a good one.